In 2019, headlines around the world declared that science had finally done what a century of detectives couldn't: unmask Jack the Ripper. The evidence? A 130-year-old silk shawl, a microscopic trace of DNA, and a single suspect. But almost as fast as the story broke, geneticists tore the study apart, calling parts of it unpublishable. So which is it? Was this a genuine forensic breakthrough, or a case study in how forensic science can go wrong? This is a case about what DNA evidence can prove and what it can't. Start with the basic problem. The Jack the Ripper murders happened in 1888, decades before fingerprinting was standard police practice, and well over a century before DNA analysis existed at all. There was no forensic collection process as we'd recognize it today. No sealed evidence bags, no chain of custody, no controlled crime scene, which means any modern forensic claim about this case has to survive a question that almost never comes up in current investigations. Can evidence from 1888 even still exist in a usable, uncontaminated form? And can we trust where it's been for 130 years? That question turns out to be the entire fault line of this controversy. The item at the center of the story is a silk shawl, said to have been found near the body of Catherine Eddowes, the Ripper's fourth victim. According to the story behind it, a police officer at the scene took the shawl home as a gift for his wife, rather than logging it as evidence, meaning it left official custody almost immediately and was passed down through a family for well over 100 years, before eventually being purchased at auction in 2007 by an author researching the case. For a forensic scientist, that history is a serious problem before a single test is ever run. Chain of custody exists to answer one question: can you prove this item wasn't touched, contaminated, or altered between the crime and the lab? With this shawl, the honest answer is not really. It changed hands repeatedly in undocumented ways for over a century, long before anyone treated it as forensic evidence. The forensic method itself was straightforward in concept. Researchers examined stains on the shawl and identified what they believed were traces of blood and semen. From those stains, they extracted mitochondrial DNA, the type of DNA passed down exclusively through the maternal line, which survives in much smaller, more degraded samples than standard nuclear DNA. That's precisely why it's often the tool of choice for old or damaged forensic material. It's more likely to still exist after a century than the DNA typically used in modern criminal cases. They then compared that mitochondrial DNA against reference samples, voluntarily provided by living descendants of both the victim, Catherine Eddowes, and the suspect, Aaron Kosminski. According to the researchers, the profile from the bloodstain was consistent with Eddowes' maternal line, and the profile from the semen stain was consistent with Kosminski's. That result was eventually published in the Journal of Forensic Sciences in 2019, giving it, for the first time, the appearance of peer-reviewed legitimacy. The scientific backlash was fast, and it came from geneticists with no stake in the Ripper mystery at all, people whose objection wasn't to the story, but to the method. Their criticism centered on a few key forensic weak points. First, mitochondrial DNA isn't unique to one person. Unlike nuclear DNA profiling, which can narrow a match down to an individual with extraordinary statistical confidence, mitochondrial DNA is shared by everyone along a maternal bloodline, and certain mitochondrial types are common across large percentages of the general European population. Some critics argued that the specific genetic marker used to link the sample to Kosminski wasn't nearly as rare as the original analysis claimed, meaning the match could plausibly belong to a large number of unrelated people, potentially including anyone who had simply handled the shawl over the decades. Second, the paper withheld key technical details. Critics pointed out that the exact genetic sequences and variants used to make the comparison weren't published alongside the study, which meant outside experts couldn't independently verify the claimed match. a significant departure from how forensic genetic findings are normally expected to be presented for scrutiny. Third, and most fundamentally, contamination. A 130-year-old shawl handled by unknown numbers of people across generations with no forensic protocols in place is exactly the kind of sample where modern DNA, from anyone who ever touched it, could easily be mistaken for DNA connected to the original crime. Put simply, on a mishandled shawl, later touched DNA can masquerade as evidence from the crime without proving when or how it arrived. That's the crucial forensic distinction the criticism kept coming back to. Even if the genetic comparison itself was done correctly, matching DNA on an object doesn't automatically tell you when that DNA arrived or under what circumstances, especially on an item with no verified crime scene provenance in the first place. It's worth asking forensically what this case would need in order to move from provocative claim to settled fact, because the gap is instructive. A more definitive case would require verified, unbroken chain of custody proving the shawl was actually recovered at the scene and stored securely from that point forward. It would require full publication of the raw genetic data, so independent laboratories could replicate the comparison rather than take the original team's conclusions on faith. And ideally, it would use a form of DNA analysis less prone to broad population matches than mitochondrial DNA alone, corroborated where possible by other independent lines of evidence. None of that fully exists here. What exists is one privately owned artifact, one research team's interpretation of it, and a swirl of historical assumption filling in the gaps that hard evidence can't. This is why, more than 5 years after the peer-reviewed paper's publication, the case is still officially unsolved, and the DNA claim remains exactly that, a claim, not a consensus. Genetic experts outside the original research team have continued to question the statistical significance of the match. Historians note that Kosminski was already a documented police suspect in 1888, decades before any DNA evidence existed, which makes it hard to fully separate the forensic conclusion from a theory that predates it. That doesn't make the DNA analysis worthless. It's a real, published, peer-reviewed piece of forensic work using legitimate techniques, but it illustrates something important about forensic science generally. A scientifically valid method applied to a sample with compromised provenance can only ever produce a conclusion as strong as its weakest link. Here, the weakest link isn't the lab work, it's 130 years of unknown hands. Jack the Ripper remains formally unidentified, not because nobody has ever proposed an answer. Dozens of suspects have been proposed over more than a century, but because none of those answers has yet survived the level of scrutiny forensic science demands before treating a theory as fact. The Shaw case is a rare, almost accidental lesson in the discipline itself. A positive DNA match is not the end of an investigation. It's the beginning of a much harder question. Can you actually prove how it got there? Until someone can answer that with certainty, the most notorious cold case in criminal history stays exactly that: cold.